manager. Right? Get a flat salary, work as many hours. Yeah. That's how it works.
Did you do a review Wednesday?
Yeah, and I posted it. Didn't you see my email telling me I posted it? Yeah. I sent you one. As in yesterday, I sent it. Yeah, on Moodle. You get an email from Moodle, right? You get the email. It says it's on Moodle. Oh, somebody check on Moodle. You get your computer. This guy is out there. Check on Moodle and see if it's out there. Should be, unless it didn't take it for some reason. Okay, so we're going to do present values and future values today. And then when are you having a quiz on it?
On Monday.
Yeah, Monday. And there is some old videos out there too from last semester or the semester before. It's not there.
No.
Really, on Moodle?
It wasn't sent. Like the email wasn't sent.
On Moodle, is it out there?
It's on Moodle.
Oh, it is out there. Okay, I thought I sent you guys an email. Maybe I did. Maybe I might have. But I thought I did. Okay. Anyway, okay. So the last two classes were there, and the review was there. We have 4 or 5 people to review. Okay, it's fine. Anyway, and then we have a review on Monday too, I guess. Isn't that what it is?
Yeah.
You're going to do the quiz, and Monday we'll have a review, and then Wednesday you have the test. Study over the credit, right? Study. Don't just come back and have forgotten everything you know. It'll be too late, right? Be too late. You'll not just screw up the quiz, you'll screw up the test too, right? They'll both do. So happens all the time. Happens all of us. So, okay. Anyway, so I have a list of things that need to get done. Right? Via email. So making people. All right. Anyway, let's do a present value problem. I'll just make one up. So easy. Okay. All right. These are the things, right? Present value. We talked these just a little bit last time. Present value, future value, some number of periods from now. We talked about the number of periods and the interest rate. And then there's one other thing. You might have an annuity payment. And what an annuity payment means, this will be an ordinary annuity payment, by the way. It's the only ones we use in this class. An ordinary annuity payment means what? Payments are all the same. No period skipped. They're all the same. Okay, none are zero. Yeah, all of them are the same payment. Every period, right? And the discount rate does not change. If that's true, you can use an annuity table. And all an annuity table does is it adds up the present, let's say it's 5-year annuity, 5 equal payments. It just adds up 5 present value of the sum factors, or 5 future value of the sum factors. And it gives you one factor you can use, which saves you time, right? You could take the cash flow from times the present value factor for each of the years and then add it all up. Or you could add up the present value factors for all the years and multiply once. That's all we're doing. When you use the annuity table in the book, right? Or when you have your calculator do it, it's doing the same thing. There's a formula for it. And by the way, are you welcome to use the formula? Sure. Okay, sometimes, well, real rarely, somebody will actually use the formulas. Okay, just decide to do that because they're real comfortable with it. Okay, but it doesn't matter. Tables use the formula and calculate it for you. Your calculator uses the formula and calculates it for you. Okay? By the way, if you use the tables or if you use the calculator, you get slightly different answers. Why? The tables are rounded off. Your calculator is not, right? Captures more. Okay, so it's a little more accurate with the calculator or using Excel. I always use Excel, of course, in real life. Okay? Actually calculate something because it's fast and easy. Better to calculate. So anyway, if I knew any 3 things here, I could calculate the fourth and the fifth one. Okay. So let's say I want to calculate a present value. So let's do an example of that. Let's say I am going to get $100,000, and I am going to get it 5 years from now, and I think I should earn 12% interest. What do? I know that I have a future value, and it happens to be 5 years from now. It's 100,000. By the way, you can set these up a couple of different ways. You either multiply or divide is basically what it is. I guess I like multiplying better. I don't know. I do. That's the way I would do it. What I want to know is the present value at time 0, right? So what I'm going to do is I am going to go look up, if I want, the present value of a sum factor. Okay, now here's the deal. How do I know I'm using a present value of a sum table to do this? Right, that's the first table, right? A1, I guess it is that right? A1. if you look at table A1, how do I know I want to use that particular table? That's the present value one, right? I think the next one's future value one, is it? And we've got a couple of annuity tables, right guys? Future value sum, so we got a present value annuity, ordinary annuity, and a future value ordinary annuity. Okay, anyway, when I look at this, how do I know I want to use the present value table? Because I know the future value, I want to get the present value. How about if I knew the present value and I want to know the future value? Which table would you use? How about a future value table? You use the table for which direction you're going. That's all. Okay, it's not a big deal. Same thing on the annuities. You can't mess up. Okay? If you're using your calculator, you tell it the future value is 100,000. You tell it N is 5 periods, and you tell it what? So N is 5. And what else do we know? Interest rate is 12%. It needs all those things, and once your calculator has that, it can calculate that present value for you. Just like that. Okay? So it's no problem. What is it really doing? It is dividing 1 plus the interest rate. This factor is 1 over 1 plus the interest rate raised to the number of periods. You know, and you look at that and you think, oh, wow, that's difficult. No, it's not. You're dividing it by 1.12 to take the interest out. You're sucking the interest out, huh? Right? You're taking the interest out. So if I got $1 a year from now, I divide it by 1.12 and find out what it's worth now. That's it, discounted at 12%. Okay? But we're going to do that 5 times here. Right? Do the division, then another one, then another one, then another one. So how would you write that, everybody? To the 5th, right? So it is. So if you take 1 over 1.12 raised to the 5th, you will get the factor that's on the table. Okay? Or if you use your calculator to do it, got a nice calculator, right? That's what it does. It's no big deal. You need to have an idea what the answer is going to look like. Do you think the present value is going to be less than 100,000? I'm getting money 5 years from now, maybe, or 5 months. It could be whatever number of periods. Okay, 5 years from now, and I'm discounting it at 12%. Do I think that money later is worth more or less now? If I'm getting the value of it now, I'm going to receive 100,000 5 years from now, discounted at 12%. Don't you earn interest? So you immediately know if you got the wrong table, you went the wrong direction. If you get a bigger number, that's impossible, right? It's got to be less. And is it a fair amount less? Sure. 12% is a relatively high interest rate, isn't it? Okay, if it was 2%, it wouldn't be worth much less than 100. If it's 12 for 5 periods, sure. Okay, the more periods you have, the more discounting there'd be too, right? Do it for 20 periods instead of 5. It's not worth much at all, huh? Especially at 12%. So the higher the discount rate, the smaller the present value is going to be. The higher the number of periods, the smaller the present value is going to be. And the reverse is true too, huh? So get an idea what it's supposed to look like. Don't just calculate this, get a ridiculous answer, write it down on the paper. I'll make fun of you as I mark it wrong. I actually have people tell me present values are more than future values. I want to do business with you. I'll give you 100,000 later and you pay me 120 for it now, okay? Deal? Any takers? Well, you write down answers that look like you do that. So don't. So what is that factor? What did you get if you went to 5 periods, 12%? Okay, it's 0.56. The factor.
No, 0.56.
5, 6, 7, 4. Okay, what's worth 57 cents? $1 received 5 periods from now at, I can't do 12, okay, at 12% interest, huh? Right, guys? That's it. Each dollar's worth 57 cents. You know why? If you invest 57 cents at 12% interest, compound, what if you took 57 cents times 1.12 raised to the 5th? Yeah, multiply times 12%, 1.12, because you want your money back to 1, right? 12% is the interest you're going to get. If you did that 5 times, it would grow to $1. That's why $1 is worth that now. How much interest would you earn if you invested 57 cents and got $1 back at the end? 12%? And how many dollars or how many pennies? So 43 cents to me, right? $1 less 57 cents. This is simple, isn't it? Right? That's how much you make. Okay? So what's the whole 100,000 worth? She said it was 56,740. Did somebody do it using their calculator to calculate present value? What'd you guys get?
56,742.7.
All right, so it's a little different, right? That's more accurate. Okay? More decimal place. Is that what you got? Okay, that's present value. Big deal, huh? What if I wanted to calculate a future value? Let's do it. Let's say we do not know the future value this time. So let's change it to that. Look at this. This could be too easy to believe. Let's say I know the present value is $56,740. Okay? Sound familiar? Okay. And I didn't know the future value. How would you get there? Let's reverse the process, huh? What do we got? I've got a present value at time 0. If I told you I was going to invest $56,740 for 5 years at 12% interest, and I asked you to calculate what it was going to grow to, it's pretty easy to calculate here because you know it's what? It's going to be the 100,000, right? Sure. I just took the present value. Of course it's going to be true, right? But if I had a present value of $56,740, and I wanted, pretend you don't know, right? If I wanted to know what the future value in year 5 is, what would I do? I would go to a table called what? I'm calculating a future value of a sum, guys. Let's go to the future value of a sum table, okay? Which table is that? A2 or something? A3 for a sum? Okay, A3. All right, good. So table A3, and what would I look up? Well, let's see. What was N? It's 5, right? What's the interest rate? It's 12%. Am I right? Okay, so what is that? That's going to be 1 plus the interest rate, isn't it? That's what they're doing. 1 plus the interest rate. Because I want my 1 back because I want my money, right? And then the interest rate, I want interest. That's all. 1 plus the interest rate. Raised to the what? 5th. So what is that? That's 1.12 raised to the 5th, which is exactly the reciprocal of this one, isn't it? All right, guys? Of course it is. You're adding interest instead of deducting it, right? Okay? It's just the reverse, okay? Inverse. Okay, so what do we do with this thing? What is 1.12 raised to the 5th? You look at the table for 5 periods, 12%. What do you get, guys? 1.7. Give me one more decimal, probably one. Maybe 2. How many do they have on the table? 1.676. 2.3. Okay. All right. And your calculator, of course, keeps more decimals. All right. So use the whole factor from the table, of course, if you're using a table. So 56,740 times 1.7623. By the way, what's worth $1.76? $1 invested for 5 periods at 12% compound interest. That's it, right? It's just compound interest. It's no big deal. Okay? So what's 56,740 times 1.7623? Yeah, you know what? That's rounding, isn't it? What is it really? It's really 100,000. Do you, with your calculator, did it work? Do you use that 56,742, or 743, I guess it was, right? Reverse it. So yeah, we'd get our value, wouldn't we? Everybody see what's going on here? If you don't believe it's the reciprocal, take 0.5674, right? Take 1 and divide it by 0.5674. What do you get? 1.7623. Right? Everybody good? Yeah. It's not a big deal, is it? So can you guys do future values and present values of a sum? Absolutely. Okay, now let's do this. Sometimes I like to do this to people. Just make sure you know what you're doing here. Guys, everything's valued this way and it's really simple. Especially with a calculator with a computer. Big deal. You can calculate anything, really, just instantly. Does the computer care how many periods it is? Does the computer care what the interest rate is? Does the computer care how many times a year you compute interest? Oh, by the way, when we do the next chapter, it's going to be bonds, right? Semi-annual. What does that mean? Pays interest twice a year. Guess how many periods you'd have in a 5-year bond if it's semi-annual? 10, just like that, right? Of course, there's 2. What if it's quarterly? 5 times 4 is 20, right? Of course. What if it's monthly? 5 times 12 is 60. What would you do with the interest rate? What would the interest rate be if it was semi-annual? Annual is 12%. What would semi-annual be? 6%. So you double the periods and cut the interest rate in half, wouldn't you? Of course. What would be the interest rate if it was quarterly? Divided by 4, it's 3%, right? Everybody good? And you'd have 4 times as many periods, 20 periods, I guess, at 3%, right? Okay? What if it's monthly? It'd be 60 periods, of course, but what would be the interest rate? 1% a month. That's it. There's just nothing to it, right? Okay? Let yourself think. Makes sense, doesn't it? Okay? All right. How about if I did not tell you the interest rate? Let's say we had this situation. If you have a nice calculator, it makes it easier for this. Otherwise, it's a little bit of a pain, but it's not horrible. We can still use the table. How about if I gave you the 56,740 and I gave you the 100,000? So here we are now. And I don't give you this one. Could you calculate it? Could you get the percentage? Yeah. With a table you can, with your calculator you can. With the calculators, you give it every piece of information except the interest rate, and solve for the interest rate. What do you think you can do for number of periods? Give them all the information except for the number of periods, it'll tell you the number of periods. No problem, huh? Same with Excel, it'll do it for you. What would we do if we're using the tables? Let's think about the tables and sort of see what's going on. I like using the tables where you're learning this stuff. I would never use them at work, right? They're inefficient, cumbersome. By the way, why do the tables exist? There used to be books of these tables, big books, right? Because you wanted to have as many interest rates as you could possibly have in the book, and as many different number of periods in the book. So you could just go look it up, right? So you'd have a big, like a big book, big thing, right? Okay? With all these present values and future values. Why did we have that? There was no such thing as a calculator. There was no such thing as a computer. So people calculated them using the formula. And we had books. You didn't have to calculate them every time. No kidding. Before my time. But I've seen the books. It's pretty funny, right? Saw people using them. What are you doing? You have a calculator, right? But anyway, although we were using a calculator that didn't calculate present values and future values, we used the formula and calculated this real fast. Okay? All right, anyway. So, by hand, I can't imagine him to do that for y'all. So you can set this up either way. We can put the present value here and the future value here, or vice versa, okay? We can do it like this, okay? Times some sort of future value factor. Oh. Or if you put the future value first and then the present value, you can use the present value factor, okay? Direction you're going. All right? So what do we know about this? I know the present value is 56,740, right, guys? I know the future value is 100,000. Huh? Is there anybody who cannot tell me what the future value factor's got to be? Of course you can. What do? You divide 56,540 into 100,000. We already know what it is, don't we? What was it? 1.7623, huh? 1.7623. So you can use the table if you want. It's fine, right? Might be a good idea when you're doing a quiz on this stuff to do both. Use your calculator, then do it by hand. Make sure you really know what you're doing. You got a correct answer. I see people who think they really understand this stuff. I'll tell you what. I just did a quiz. Now, their problems are much harder. It's present value and future value with annuities. And there's something called an annuity due to. Ordinary annuity means payments at the end of the period. I guess ordinarily at the end of the period. Guess what an annuity due is? Payments at the beginning of the period. Yeah, I won't give you any of those, but that's all it is. It's no big deal. But of course, they have different values, right? There's one more period. Periods if it's payments at the end than at the beginning, huh? That makes sense? Okay. So that's different for present value and future value, which kind of drives people crazy. Anyway, I gave a 25-point quiz. I had a 4 on it. The high was 16, 25-point quiz, an intermediate. And they all thought, I know how to do this, I know how to do this. Happens every single semester. Guess what? They didn't really. You guys don't either. Now, these you might find pretty easy just getting started here. But you don't really know how to do this stuff. Work on it, work on it, work on it to get it down. If you're going to be accounting or finance type, oh my gosh, you want to think this way. You never want to think a dollar is a dollar, right? They're at different times. Because they're not. Right? What if I offer to pay you $100,000 and you don't have to do anything illegal or immoral? Right? I'll pay you $100,000 to work for me next year, okay? How many of you would take that? And none of you guys make that kind of money, do you? I'll give you $100 to work for me. You guys like that? That'd be good, huh? It's even fun. It's even fun. Oh, I'm not going to give it to you for 100 years. I'll put the money in the account. We'll let it grow. You're guaranteed to get it, right? It'll be in trust for you. And 100 years from now, you can get it. How much money do I have to put in the bank right now? I bet that's less than 1,000. 100 years. Depends what the discount rate is, huh? So how much am I really paying? The 1,000 I put in the account, and it sits there and it grows, and you get the interest too. What a deal, huh? But all you got paid was 1,000 to work for me for a year. You'd be a crazy person to take that, right? Okay. What if I offered you 100,000? I'm going to pay you in 5 years. Would you want to know how much that's worth? Uh-huh. Yeah, you would. You'd discount that back to now, wouldn't you? Absolutely. Okay. So that might not be a very good deal either. I wouldn't like that. Well, look at this at 12%. What was it, 5 years? 12%? Worth about half as much? Not so good, is it? Okay. So anyway, now how would I get the interest, okay? How would you get the interest here? You could do that. That would work. I like that. Math guy. That's good. But it's a real simple way to do it if you're using a table. So you don't even have to have a table. It's got it, right? Absolutely. What could you do? Take a look at the table. Look at 5 periods. We don't have the interest rate is all we don't have, right? We know n equals 5. What we don't know is the interest rate. I really like that. I rarely get somebody to do that. It's cool. Good for you. Okay. Learn something in math class. Okay, so yeah. Anyway, what's the interest rate? Go to the table, right? Go to 5 periods. Go to the future value table because that's the direction we're going here, right? That's the future value factor. Go to the future value table. Go to 5 periods and go across until you find 1.7623. What column are you in? When you do that, what column did you get in? You guys don't bring your book to class still. Something else. Oh, it's 12%. We knew it was going to be, didn't we? But that's all you have to do. Okay, what if I didn't know the number of periods? Let's do the same thing. Oh, I'll do it the other way around so you guys can see how that one would work too. Let's put the future value over here. Either way is fine. I don't care which way you do it. Let's put the present value over here, okay? Number of periods was what? So what? By the way, what factor am I going to use now? If I know the future value and I want to calculate the present value, it would be what? Present value factor. So we're going to go to the present value of the sum table this time, okay? Because I'm using a different factor, that's all. So I got the 100,000 over here. Go in the opposite direction. This one's 56,740. We already knew what that factor was. We already used it, didn't we? What's that factor? 56,740 divided by 100. I think it's 0.5674, don't you? That's the factor that we looked up before anyway, right? But if you knew the interest rate is 12%, could you find the number of periods? Do exactly the same thing. Go to the present value sum table, right? Go over the 12% column, go down until you find 0.5674. And what is that? What number of periods is it? It's 5, of course. Right, guys? We can do this, can't we? So don't panic if I ask you something different. Who cares? So what's the deal? So far, if I know any 3 of those 4, I can calculate the 4th one. Make sure you can do that, okay? That's all. Using table, using calculator, I could care less. I would do both if I was you guys. Okay? Got it? Have you done this before? You told me that last time you hadn't done this before. You have, haven't you? You just didn't know what you were doing. And you didn't call it present values, future values, because they weren't working with money. They were working with math. But you know what the most common application is of this? These are exponentials, right? This is the most common application. Everybody uses this all the time. Okay? You work for any business, anywhere in the world. Right? You do this. So you do it all the time, constantly. Because you don't exchange the money at the same time, right? By the way, what if I was going to pay you right now? $1 a dollar at any discount rate, right? No time. 0 time. There's no interest. There's no time. You guys know that, right? Okay. But what if there's time? Even a year. I want interest, don't you? Absolutely. Okay. So that's it. All right. We don't usually do it for a month or something. We don't bother. Right? So, okay. All right. Let's add annuity to it. Okay. Let's add that. So let's go back to having our 12% interest, I guess, and let's do an annuity payment instead. Okay. by the way, you can do the same thing for the number of periods and for the interest rate using annuity tables too, works just fine. Get the factor and go to the table and find it, right? Okay, but let's get an annuity payment if I wanted to, okay? Let's compute what an annuity payment would have to be. Or we can compute what an annuity is worth. So let's do another sheet, and let's take a look at this. Let's have an annuity payment, and this is an ordinary annuity payment, which means what, guys? Same amount of money every period, right? Same amount of cash flow every period. No period skipped, and the interest rate does not change, okay? So let's say I have an ordinary annuity payment of $10,000, okay? Let's say my number of periods, let's make it 10. So by the way, how much cash is going to change hands? 10,000 times 10, right? 10 periods. So the total amount is going to be 100,000. I think it's a good idea to compute that. It's not an answer to anything. It's just, hey, if I'm calculating the present value of 10,000 that I'm going to receive in the future, what do you bet it's less than 10,000? Take an interest out. If I'm calculating the future value of 10,000 I'm going to invest, 10,000 10 times, so I'm investing 100, I bet that's worth more than 100. What do you think? Is that a valuable number to think about? Well, yeah, you got a gauge, right? Obviously, the more interest there is, the further you're going to be away from the 100 for future value or present value. Okay? The lower the discount rate, the lower the interest rate, the closer you'll be. And the same with the number of periods, right? Okay, so, all right. And let's say our interest rate, let's use 8%. So here's the deal. Let's calculate a future value first, okay? Let's calculate a future value. By the way, with those three pieces of information, I can calculate a future value or a present value. So second, what I'll do is I'll use the same information to calculate a present value. And of course, if I knew the future value, I could calculate the present value. And if I knew the present value, I could calculate the future value, right? Put all this stuff together. Okay, so here we go. Let's go ahead and calculate a future value. What would you do? I'd take my ordinary annuity payment, how much is that? Ordinary annuity payment, $10,000. Okay, and that represents 100,000. It's 10,000 at the end of each period, right? Okay, and I'm investing this money, so I'm calculating the future value, right? It's going to grow, so I'm putting 10,000 in at the end of each period, huh? Right? Okay, or from the bank's perspective, it's giving you to do the same thing. How much would you owe later, right? How much would be in the account? All right. And I am going to calculate a future value. How many periods from now? Ends 10, right? Everybody good? I want to know its future value 10 periods from now, don't I? That's it. That's what I'm doing. Okay. So, what's my interest rate? I used 8%, right? What's my number of periods? It's 10. It's a 10-period annuity, huh? What kind of a factor do you want here, gang? I know the payment, and I want to get its future value. What do you want? Payments are earlier, okay? Like a present value. What do you think? This is going to be a factor for a future value of an ordinary annuity. And they just call it an annuity in your book because they didn't give you the annuity too. Oh! So, let's go to the future value of an ordinary annuity table. And let's look up 8%. Go down to 10 periods. What's the factor? Is it going to be more or less than 10, by the way, seeing as we're adding interest here? More than 10, you bet. Okay? What is the factor? 11.4351. 11.4359. What's worth $11.44? $10. Listen to this carefully. What's worth $11.43? 44 cents. $10 invested $1 a year at the end of each year, right? All of them compounded at 8% interest. The first payment you put in is going to be there for 9 years. You put it in at the end of the first year, right? And it compounds interest for 9 periods. So you can do the future value of $1 for 9 periods if you wanted. right? That's on the other table, okay? Future value sum table. Then the second one is what? It's going to be there for 8 years, right? Comes in at the end of the second year. Compounds 8 times. Got the idea? Next one 7 times. The last one doesn't compound at all, does it? That's why the factor for one period is 1. If you put the money in at the end of the period, what's it worth at the end of the period at any discount or at any compound rate? Still up, right? So what they did was they added up the future value to sum table. That's all they did. They added up the future value to sum table. Okay? For the first 10 periods. They've got it. Okay? That's it. So they did it 40 on the table. Otherwise, what you could do is you could do 10 multiplications. You could take 10,000 and compound it for 9 periods, right? And then 10,000 for 8, 10 for 7, 10 for 6, all the way down to 10 for none, right? The last one. And add them all together. Imagine if it was 100 periods. It'd kind of be annoying, wouldn't it? Or 200 periods. So we got tables. Or if you plug in your calculator, what do you put in your calculator game? The annuity payment. You tell it it's a payment. You tell it it's at the end of the period, which on your calculator is 1, or some calculators it just says n, right? Tell it when it is, okay? So you tell it it's at the end of the period, that it's $10,000 per period, the interest rate's 8%, the number of periods is 10, and guess what? It'll calculate the 11.4359 for you, take it times 10,000 and give you the answer. No kidding. So if $10 is worth $11.44, what's 10,000 10 times worth, right? Which would be the 100,000. What's the whole 100,000 worth, everybody? How much is that? What's 11 times 10? 1, 1, 4, 3, 5, 9. Where does the comma go? 114, 359, isn't it? How much interest did you earn? You know, you invested 100,000, you got 114, 359. What'd you earn? 14, 359. Got it? Which is what? 8% interest. 8% compound interest. Okay, now let's calculate the present value. So this is 114. You guys need to practice a few of these problems now. There's a bunch of them in the book, right? And you can watch review sessions where I did this stuff, talk about it. Okay, here we go. All right, not there. Well, that's, I worked most of the quiz in that review session, by the way. That's how I did it. All right, let's do then the present value. That's at time 0, right? So what we're going to have is the same ordinary annuity payment. By the way, you could set it up as a division instead of a multiplication if you want. I think the author might do it that way. It doesn't matter. Go either direction you want. Okay? This is going to be what kind of a factor? Seeing as I want to calculate the present value again. Present value of an ordinary annuity, right? Isn't that true? Okay? So that factor then would give me the present value. Okay? So what's the present value of this thing? Look up a factor. What's the interest rate? 8%. What's the number of periods? 10. Okay, now let's think about this. Is that factor going to be more or less than 10? You're taking interest out.
Less.
It's got to be less. Of course it is, right? Okay? You're taking out 8%. Right? On the last payment, you're taking out 8% for 10 periods, right? So the payments come at the end of the period. Second to last payment, taking it out at 9%, or I'm sorry, 9 periods, 8% for 9 periods. The last payment is going to be, or the first payment is going to be what? 10,000. The first payment is going to be what? Discounted just for 1 period, because it's the end of the first period. So when you're doing annuities, the future value and the present value is 1 period offset, huh? Okay. All right. So what do we got? What's the factor if you look it up? 8% for 10 periods. Present value of a sum table. It's got to be less than 10, and it's certainly going to be more than $1, right? No. So you get on the right table. Okay. Can't miss. If you know what you're doing, you can't miss. Okay. Can't grab the wrong table. What is the factor? What is it? Point what? Or I'm sorry. It's about 7 or something. 7 or 8. We're doing 8%, 10 periods. You want to grab that for me?
Are we doing the sum table or
No, no, no. This is an annuity. It's a present value of an ordinary annuity table. There you go. 5.3341. What that is that what it was? Last one. I thought it was 7. But that wasn't a very good guess, was it? I guess 10 periods is quite a few, even though 8% is not a real high interest rate. So what's worth $5.33? $10. That's what it's worth right now, right? Where you're receiving $1 at the end of each period for 10 periods. That's it. You know how they got that table? They added up 10 factors. One for 1 period, 1 for 2, 1 for 3, 1 for 4. Look at the present value of the sum table. If you added up the first 10 numbers, right, that are in the 8% column, if you add up those first 10 numbers, you are going to get 5.3349. Just do the first 3. Take a look at the first 3, add those first 3 up, and then look at 3 years on the annuity table. If that's what it is, it won't be exactly to the penny because it's a formula, it's not accurate, okay? They don't round it until they get the answer. That's it, big deal. So, by the way, is it intuitive? I guess $7. Is it intuitive all these years? I still, calculate, right? Is it intuitive how much it's going to be? Not really.
Wait, the 10 period is at 8%?
Yeah, did you give me the wrong number?
Yeah.
Nobody said a word. Nobody's looking it up. You guys already know how to do all this stuff, right? Or are you already on vacation? You're supposed to not be going on vacation at all. And by the way, you can trust your calculator if you want, but remember, you input stuff to the calculator wrong. What happens? Oh well, you'll give me a ridiculous answer. And if you don't have an idea what your answer is going to look like before you start plugging numbers into the calculator, you're going to miss a lot. You just will, and you will in real life too. Okay, if you don't have an expectation before you do it, that computer, that calculator could care less what the answer is. It doesn't have a clue what you're doing, right? The hard part of this is, you know what really is going to be tough. In 211, we just started that yesterday. Keep going today with it. They have to determine what the interest rate should be, and they have to determine what the number of periods should be, and they have to determine what the cash flows are going to be. All of them. And then they calculate present values and future values. That's the hard stuff, you guys. Not doing the calculation. The calculation's a joke, right? But if you don't know what you're going to put into the calculator or the computer, you're worthless. Okay? Knowing how to do this, so what? You don't have to know how to do it. Your calculator does it, right? I'm not trying to teach you to use the calculator. I'm not trying to teach you to use tables. I'm trying to teach you how to do this, okay? That's where we're going with this. Nobody's going to care that you can do the calculations. So what? Anybody can do that. I don't need you for that. I can do that in a millisecond. I have a spreadsheet. I just plug numbers into my Excel. Why would I hire somebody to do that? If I want to know, I can just do it. I can do it with a calculator instantly. You can sit in a business meeting. Anybody can sit in a business meeting and pull out their calculator and calculate it. You have to know what numbers to put in. Got it, guys? That's the hard thing. Does 12% or 10% interest over 25 years make a difference? Those two? Oh my gosh. Okay, what does an 1/8% interest do on a 30-year mortgage, you guys? It's astronomical difference in how much you paid for your house. You just wouldn't believe what happens. We care about really tiny portions of interest over a long period of time. For a year, it's a lot. Who cares about an 1/8 of a point, right? Oh, I don't know. If it's on $1 billion, I'd still care, I guess, right? That's how big the deal is. All right, anyway. So what's the whole thing worth? If $10 is worth $5.33, what's 10,000 times 10 or 100,000 worth? 55,000. 334.90, I guess. Okay? That's it. That's the answer. Be able to do this game. 335. Okay? Be able to pull this off. Easy? Yes, sir.
Why don't we do the actual?
Oh, was that the wrong number?
Yeah.
Yeah. I didn't change it. Good man. We do want to fix that. How much was the real number?
6.7101.
Oh, it wasn't as far off as I thought, right? I guess so. Way to go. Oh, yeah, that's fine. Okay. Is it really easy to read the table or the wrong?
Well, I was doing, I did.
Oh, you did 8 periods at 10%. Yeah, instead of 10 periods at 8. I got you. Okay. So it was fairly close to 7. All right, so that's 67,101. By the way, if you knew one of these values, could you calculate the other one pretty easy? Uh-huh. Right? You know a future value? Could you calculate a present value? Yeah, present value, future value. Sure, it's the same thing, right? Okay. Everybody good with this stuff? Easy? No. You might think it is, but no. Calculators are really dangerous things when you're trying to learn. You find out when you're doing math, how many of you had teachers that let you use calculators? What level were you when they started letting you use calculators? Third grade? Middle school, yeah. Think it's a good idea or a bad idea? Well,
I think it's a good idea.
it's tough, isn't it? It's a good idea you know how to use a calculator.
And because you use calculators in the real world.
I know. In the real world you do. Do you know what you're doing when you use them? Okay, that's the trick.
It's harder to do like calculus.
Oh, doing a calculus by hand is just a real pain. But you know the thing about it, if you do it by hand, oh my God, you know. Oh, jeez. But then you never would do it by hand, of course. You're right. So is it worth doing stuff by hand? Well, you know what? This whole class is by hand. Nobody does accounting by hand. They don't do that. Everything's on the computer. You guys could read financial statements when you got here, right? Like I said, the first day of class, how long you been able to sound out words? How long you been able to read numbers? You wouldn't know what the hell you're reading, that's right. And that's the problem in trying to teach math nowadays, right? They should give you a calculator after you know how to do it, right? Not before. Because before, what do? Exactly what you guys are doing to me right now. I know how to use a calculator, he's nuts. And I'm going to give you your scores. It'll be fine, right? Because you know how to use the calculator, you just don't know how to read the problem. Oh, you're not going to know what the cash flows are. You're not going to know when they are. You're not going to know what the discount rate is. You're not going to know if I'm asking you for a future value or a present value, unless I say it, right? Which a lot of times I don't. I'll say really tricky things like, how much would you invest now if you're going to get this amount later? What am I asking you for? I want to know how much you're going to invest now. It's now. What is it? It's a present value. You have to be able to think a little, right? What if I said, what's your car payment going to be? 60 payments. It's not future value. What's your car payment going to be? It's a payment. It's an ordinary annuity payment. What do you need to know to calculate that ordinary annuity payment? You need to know how much you're paying for the car, which is its what? You're paying for it now. They get their money now. You're paying later. They get their money now. You're not investing in it. It's going to grow or something, right? What you're paying for the car is its present value. And then what else do you need to know to figure out what the payment's going to be, which is the ordinary annuity payment? The car payment's at the end of the period or beginning of the period? Might be an annuity due if it's at the beginning, right? No, you make a down payment at the end, right? And the down payment, what does it do? It's cash now. The present value of that is whatever it is. So you'd subtract the down payment from the car, wouldn't you? All right, guys? From the full amount you're going to pay. True? And now you know what the present value is of the amount of the loan, right? The amount of the loan is the present value. What else do you need to know, you guys? I said 60 months, didn't I? N is 60. What else do you want to know? You calculate it. One other piece. Interest rate. That's it. If you have that, you can calculate it. If you guys don't realize that that's what that business deal is, mortgage on a house is exactly the same thing, except it's 30 years, and they pay monthly. How many periods is that? 30 times 12. It's 360. 360 of those things. Yeah, you do a 30-year mortgage. Okay? What do you need to do that one? Get that paid. Same thing. How much did you pay for the house? Less your down payment, because it's now, right? Of course, that's still how much you're paying for the house. It's included in it, of course. Okay? That's how much you finance. 360 periods. What do you need to know? The only other piece. Interest rate. Right? No problem calculating these things. You don't go borrow money and have the person loaning you the money tell you what the deal is. You go in and negotiate the deal. You already know what you're going to do, right? And trust me, they know what they're going to offer you. And if you just take whatever, okay, they'll be thrilled. Because they're going to give you an offer where they make a lot of money, of course. What are you going to do if you have any sense, if you know what you're doing? You say, whoa, nah, that's too rich. See ya. And oh, wait a minute. Or if you really want to do business with them, right, you're not just shopping, right? You want to do business with them, what do? Then, you got way too much interest in it. Or you got too high a price, or you whatever, too much fees and all that stuff, right? And I'll offer you this, you can counter. And they'll say, well, no, that's below market interest. No, the market interest rate is such, and that's what I factored in here. And yeah, it's a good rate, but I can go somewhere else and get a good rate. I have good credit. You know what they'll do? They will loan you the money so you don't walk away with their profit that they could make off of you, right? Versus you just take it, right? Whatever. So you guys really want to know this, and I know it's the day before a holiday starts, but you don't have a holiday. I'm trying to impress that on you. You don't really get one, okay? You're college students, right? You don't get one. So enjoy the weekend. I think it'd be safe to take 2 days this weekend and 2 days on the other weekend and work maybe 50 or 60 hours in between during the week. And you'll just be golden in all your classes. Your midterms will be fantastic. Your papers will be done, right? Work hard. See what it feels like. See you guys. Thanks for showing up today, by the way. You know, on an organized shift day, Friday before a 5-day holiday, 5 days from school. 9 total, you guys. You know what it is? 7, 8, 9. Yeah, 9 days. Yeah, 9 days. That's pretty good. And I only want you to work 5 of them. You gonna do that?